All right, in this video, we're discussing the hypothesis in hypothesis testing. So a hypothesis in statistics refers to a statement about a population parameter that can be verified or tested using sample evidence. So that's a very good definition of a hypothesis for a statistics class, right? So you might have heard people say a hypothesis is an educated guess. We don't really care about that, right? What we care about in statistics is not so much whether the idea is educated or not, but whether it can be verified or not, right? So can we go out and collect evidence and either support your hypothesis or fail to support the hypothesis? Or can we reject your hypothesis or not reject your hypothesis based on sample data, right? That's what we care about. So it doesn't have to be educated at all, in fact, right? It could just be some random statement. As long as it's testable, then we can run our procedure on it. So that's what we care about. All right, so for example, the Department of Transportation in Florida claims that the average distance driven by Florida drivers is less than 40 miles per day. Now, this is testable, right? So it's saying the mean amount of miles traveled by Florida drivers is less than 40 miles per day. We can test this in lots of ways, right? We could randomly select people and just survey them about their driving habits, or we could randomly select people and then ask them to agree to let us put some monitoring device on their car to see exactly how much they travel, and then over a set period, and then we can use that sample data to test and see if it in fact seems that the claim by the Florida Department of Transportation is valid, right? So those things can be tested. That'd be an example of a hypothesis in our course. All right, once we have a claim or a hypothesis laid out there by somebody, we can then take that hypothesis and work it into two competing hypotheses for the purpose of a hypothesis test. And so what we're going to do is basically take that same claim and break it up into two hypotheses, the first of which we're going to call the null hypothesis. So here's what you want to know about the null hypothesis. The null hypothesis usually expresses the status quo belief. In other words, it is initially assumed to be true, right? That's typically the case. It's certainly going to be assumed to be true even if it wasn't the status quo thing that was out there. When we run our hypothesis test, whatever becomes our null hypothesis, we will run the test as if that hypothesis is true and valid. We're going to use notation h sub 0. H sub 0, and the sub 0 you might recognize from maybe science classes where that represents sort of the initial condition, going back to this idea of initially assumed to be true, right? So h sub 0, you'll hear me say the null hypothesis often, or sometimes you might even hear me say HO. That's actually not correct to say HO, but it's okay. Lots of people do it and it's really not a problem. All right, the null hypothesis uses one of the following three symbols. It'll always use either greater than or equal to, less than or equal to, or equal to. And the reason why it uses always one of these three symbols is a major property of the null hypothesis is that it contains the condition of equality. In other words, it has an equal sign of some sort. Now, going back to this idea that it is initially assumed to be true during the process of testing a hypothesis, it becomes very important because that means that the null hypothesis wins by default, right? So in other words, the null hypothesis does not require supporting evidence. You don't have to support it with data. It's assumed to be true, so it kind of wins by default. So it can win a hypothesis test by default. If there is not enough evidence to reject the null hypothesis, it will continue to be assumed true, right? So that's really important, the idea that essentially the null hypothesis is a champ, right? It has to be overthrown, and you have to overthrow it with sufficient evidence. If you don't have enough evidence to toss it out, or if it's kind of on the wire or on the fence and we're not really sure how to go, we'll side by default with a null hypothesis. All right, that brings us to the alternative hypothesis. So the alternative hypothesis is often called the research hypothesis. And it's the hypothesis that bears the burden of proof. In other words, if you have a research hypothesis or the alternative hypothesis out there and you want to, make it become the new sort of law of the land or the new belief system, you're going to have to provide sufficient evidence for it, right? In other words, it can't just, win by default like the null hypothesis can. You're going to have to provide ample evidence to make sure that it looks clear enough to us that we are willing to toss out the old belief and replace it with this new belief that you've come up with. All right, so basically the alternative hypothesis is similar to the null hypothesis, except for we use the notation H sub A for alternative. You sometimes see H sub 1, and that's okay too. The alternative hypothesis uses always one of these three symbols, either less than, greater than, or not equal to, right? And again, going back to what we just said before, just to emphasize that the alternative hypothesis requires supporting evidence. In a hypothesis test, the alternative hypothesis is not assumed to be true, so there must be sufficient evidence in order for you to support it. If there's not enough evidence to support the alternative hypothesis, we will not support it. In other words, it will sort of not win the argument, right? And that's basically it. That's a little brief introduction to the two types of hypotheses that we use during a hypothesis test.